Welcome all. Today we are going to discuss about polymers. The term polymer is derived from the Greek words poly meaning many and mer meaning part or unit. That is polymer meaning many parts. The science of polymers is divided between biological and non-biological polymers. Biological polymers form the very basis of life and the food on which the life exists. Non-biological polymers forming an indispensable part of man's clothing, transportation, utensils, shelter, communication, and so on. This helps the mankind live a convenient life. Okay. The next is polymers and polymerization. So what is a polymer? A polymer is a substance of high molecular mass, each molecule of which is built up by the repetition of a large number of simple chemical units, generally called monomers. So what is polymer? Polymer is a substance which is built by the repetition of a large number of monomer units. For examples, starch, proteins, polythene, pterylene, etc. So the process is called polymerization. The process in which a polymer is formed from its simple monomer units is called polymerization. For example, polymerization of ethylene to give polythene. Ethylene molecule is CH2 double bond CH2. N number of this ethylene molecule in the presence of oxygen traces heat and pressure will give polythene, that is CH2 N times. The next example is polymerization of vinyl chloride, and then next is polymerization of propylene, and the last one is polycondensation of hexamethylene diamine and adipic acid yields the polyamide nylon 6,6. So the first three examples are polymerization reactions, and then last one is polycondensation of two monomer units, that is hexamethylene diamine and adipic acid, to give nylon 6,6. Vinyl chloride and propylene yield its polymerization reaction in the same way of ethylene. The last one is polycondensation reaction, that is these monomer units hexamethylene diamine and adipic acid will give nylon 6,6 on polymerization. The next is classification of polymers. First is based on the origin of polymers, that is natural and synthetic polymers. So the classification of polymers on the basis of origin, we can divide this into natural and synthetic polymers. First is natural polymers. Polymers of natural origin are called natural polymers. These are the polymers found in nature. Some examples are starch, cellulose, proteins, rubber, etc. In starch, the monomer unit is alpha glucose. In cellulose, the monomer unit is beta glucose. In proteins, the monomer unit is alpha amino acid. In rubber, the monomer unit is isoprene. The next is synthetic polymers. Polymers prepared by man are called synthetic polymers. Examples are polythene, PVC, pterylene, etc. Okay, are examples for synthetic polymers. In polythene, monomer unit is ethylene. In PVC, monomer unit is vinyl chloride. These two are, we have already seen the polymerization reaction. Then next is pterylene. The monomer units are terephthalic acid and ethylene glycol. So the next classification of polymers is based on its structure. So the polymers are divided into linear polymers, branched chain polymers, cross-linked polymers. In linear polymers, polymers in which the monomer units are joined together to form long chains, which are then stacked one over the other to form a well-packed structure, are called linear polymers. These are high tensile strength. These have high tensile strength. For example, high density polythene, nylon, etc. Okay, so in linear polymers, polymers are formed by the monomer units, and monomer units are joined together to form long chains. Then these long chains are stacked one over the other to form a well-packed structure. In the next section, that is next type of polymer, that is branched chain polymers. The polymers in which the monomer units are joined together to form long chains with branches along them are called branched chain polymers. That is, the monomer units are joined to get a long chain, and then these long chains are joined by branches. The long chains are having branches. These are branch chain polymers. Then these are having low tensile strength. Low density polyethylene, glycogen, etc. are examples for branched chain polymers. The next is cross-linked polymers. Polymers in which the monomer units are joined together to form a three-dimensional network structure are called cross-linked polymers. Bakelites, melamine, formaldehyde resins, etc. are examples for cross-linked polymers. These are hard and rigid. Okay. In this cross-linked polymers, the monomer units are joined together to form a three-dimensional network structure with cross-linked structure. Okay. So in the first one, linear polymers, these are having high tensile strength. In the next one, branched chain polymers, these have low tensile strength. The next one, cross-linked polymers are having hard and rigid structure. So when we see the pictures of linear, branched chain and cross-linked polymers, we can see that in linear polymers, the long chains are stacked one over the other to get a well-packed structure. In the branched chain polymer, we can see branches in long chains. Then in cross-linked polymers, there are cross-links between each long chain. Okay. Thank you.